Hello everyone, this is Peter Gedai from ManageXValue.com. This video is an introduction for a series that focuses on the power and utility sector. I lived for more than a decade in California and worked with multiple power and utility companies across the United States. And unfortunately, given some of the risk events in the past and the regulatory requirements that emerged from those risk events, risk quantification is an important topic for these organizations. So with this series, we wanted to provide an overview for these companies to really demonstrate that with a scalable risk quantification approach, how they can assess their risks in a very structured and easy to understand way, how to communicate these risks, but most importantly, how to plan and evaluate their risk mitigation plans for the regulators and for their own decisions, why they can actually manage the risk within the organization, considering multiple stakeholders that they may have. As you can see in the current risk assessment dashboard, you typically get the loss exceedance curve that can be compared to the risk tolerance. While this may seem to be high in absolute terms, but for this hypothetical company, this is just a small portion of the market capitalization, or even smaller for the total invested capital of the business. And the risk tolerance is already defined by the hypothetical management team for the business. So to better understand what the business really looks like, we can start with the hierarchy views. As you know from the previous videos, the platform performs a Monte Carlo simulation, but now we see the expected result, even though you can switch to minimum and maximum and whatever percentage you want to focus on in your analysis. But for decision-making purposes, the expected result is typically a very useful data. So you see here the hierarchy of the organizational units. Consider this as your financial reporting view potentially. It is not necessarily granular from a risk perspective because it is much more for reporting purposes. But as you can see for this organization, there is an electricity and the gas business. And then the different sectors or different focus areas like the generation, transmission, and distribution part. And for the gas, there is transmission and distribution itself. Now, from a risk events perspective, there are many more risk events, obviously, that can be relevant for an organization. Service disruption is one of them, applicable for both the electricity and the gas business. These are typically called the reliability risk events. Customer data is more and more relevant as more and more of the services become digital and there are more and more smart assets linked to the infrastructure. Health and safety is a critical part, considering public health and safety, but also the employee health and safety that can be relevant for each and every one of these organizations. Now, another potential area is intellectual property events. This organization may have some intellectual property or other advancements that they want to protect. There can be property damage as well, relevant for the business itself, considering the significant investments in the infrastructure, and then some competitive events as well that can drive their business. Of course, every organization, all our clients can start with a blank sheet of paper for the initial design and then define as many and as different type of risk events as they want to. Impact areas is relevant from the perspective that they focus on financial impact that can have the lost profit, mitigation costs, and fines and penalties, as we've seen in the past. But beside it, there are non-financial strategic impacts as well, considering some of the risk events. So, for example, it is important to really focus on health and safety public health and safety and employee health and safety from an impact perspective, because it's strategically very important for the organization to make sure that there are no such risk events that can have negative impact for their other stakeholders, and consequently in the longer run it's a negative impact for their operations as well. And of course, loss of customer trust and regulatory impact as well as negative environmental impact. Each and every one of the organizations define their own strategic value drivers or strategic hierarchy and the impact areas. Typically, these are relevant for power and utility companies. When we look at the various threats, again, this is a more complex than the organization structure, even though this is a pretty small scale of a demo. As you will see in a moment, it can actually scale even more. But within the threats, physical security threats are typically important. Some of the competitors' actions can be relevant from a competitive advantage perspective, regulatory actions. Natural threats are also threats that are important: extreme weather, extreme heat like in California, extreme cold like in Texas, earthquakes applicable for California as well, and then tornadoes, other parts of the United States or other parts of the world as well. And then digital security threats, of course, IT and OT assets can be targeted by malicious actors or even potentially by like non-malicious or accidental actors as well within the organization or outside of the organization, as you will see later. Attack surface is one of the most important and relevant dimension of any risk quantification analysis in our platform. This is just an illustration again, but what you see here is that from an attack surface perspective, of course, operational assets are one of the most important ones. And here you can see that even if at small scale we demonstrate that it is possible to do risk quantification even at the asset level. So as we separate the various power generation, transmission, and distribution infrastructure, we can start splitting those up into various regions and sub-regions, essentially. Ultimately, the platform is set up in a way that companies can scale even to the pipeline segment level if they wanted to. Of course, that also means that more and more information is needed to assess the various risk events related to each and every one of the segments, the frequency of various threat actions happening potentially, what are the risk control measures that can be used to mitigate those risks, and so on. But the platform is set up to scale even to that level. Now, gas operational assets are not as detailed as the electric ones. It's more an aggregate view. Of course, in these situations, you have to focus on the assumptions as well. You have much more uncertainty around the assumptions because you have much more aggregated focus points when you do these evaluations. The more and more you make these hierarchies granular, essentially your specification increases, and as a result you can be much more specific around the assumptions as well. But that's for another topic in the future. IT assets, typically relevant for the cybersecurity threats as well, even though they can also trigger some reliability issues. Operational buildings, the control centers are here, definitely could be targeted by various malicious and non-malicious actors, and then can cause reliability risk events. And employee network is typically an area that we put in for illustration purposes to be able to capture enterprise risks when there are emerging business areas for the organization. There are critical employees who need to be protected to make sure there is not any issue if they leave the organization. Actors, as you see, There can be malicious and non-malicious actors, so employees could be either malicious or non-malicious, but obviously there are some specifically malicious actors, even though these are just a few of them. And then there are other business influencers who can actually impact the organization itself. Nature is an actor because we have seen the risk areas or the threat actions that is initiated by nature, essentially, like the tornadoes and the earthquake. And then non-malicious external actors like construction workers, essentially, who can indirectly cause some risk events, even though they definitely don't intend to do that. So as you see, a lot of complexity can come in considering these dimensions, is how everything is connected, even though these areas of focus are really linked in a very natural and logical way in the platform. The combination of these can be significant. As you can see, there are more than 500,000 potential connections defined between these areas. However, these 500,000 connections are only a small portion of the billion that clients can actually define within the platform. Now, another way to illustrate what the risk platform can potentially look like for organization is in the Sankey chart. This essentially illustrates the risk web design of the whole calculation logic. Of course, for the whole enterprise view, it can be too much information. But as always, clients can just focus on specific areas. For example, looking at the gas operations, it is easy to understand and see, or easier to understand than looking at the enterprise level. Who are the potential actors? What are the potential attack surfaces that can be targeted, and by who and how? And for example, we can have gas pipeline digging. Who could construction workers and customers can potentially, and some other actors could potentially do that. It is easy to identify what are the proactive control measures, because the model already links the ones that are relevant for this type of threat action. But it is also possible that an earthquake can potentially be relevant, obviously initiated by, it's a natural threat action. And then, as you can see, there are no proactive control measures assigned to an earthquake. They go straight through the risk events within the organization. And then once we have the various risk events that can define what are the potential impacts, what are the proactive control measures for each and every one of the risk events within organization units, and as a result, what is the residual risk. Now, this is the gas operations, but clients can easily manage the electric business as well. Given that the attack surface was defined at a more granular level, you can easily see it here as well, that this risk web looks even more detailed than for the gas business. As you can see, there are some OT, operational technology related attacks that are mapped to various proactive capabilities. But there are some assets or some risk events that are not mitigated by various actors or various risk control measures. And finally, the last area, just to illustrate, is the IT or cybersecurity related view. As you can see, there are various IT assets typically targeted by cybersecurity threat actions. And then here, for example, man-in-the-middle attacks don't have any proactive risk control measures assigned yet. So that's probably an easy area of focus if it is significant enough for the business to mitigate considering the consequences and the various risk events and impacts. Now, within the platform, with these many connections, essentially the clients can automatically see, in this case, 2086 scenarios, risk scenarios. When we define risk scenarios, there's a very specific of an actor. Who is the potential threat actor? What is the potential threat action that can target specific attack surfaces? And if it's not mitigated well enough by the proactive capabilities, for which it's easy to see the relevance and the strengths of those proactive risk control measures or proactive capabilities, what is the specific risk event in what part of the organization that would happen, and of course what are the relevant reactive capabilities and how strong they are. So clients can easily see what are the most significant and most importantly understand what potentially drives their efforts to mitigate these risks. So these risk inventory items or risk register is automatically generated for the business. And lastly, just to illustrate that the organization has already mitigated significant amount of risk, considering the various loss exceedance curves, essentially the unmitigated risk would have been much higher than the current one. But considering the proactive control measures, a significant portion of that risk is already mitigated, and considering the reactive control measures, even more mitigation has been already achieved. So this is how, essentially, with the Monte Carlo simulation, we get the loss exceedance curve that can be compared to the risk tolerance. So for the future videos, we are going to use this power and utility demo environment to illustrate the most relevant points for power and utility companies. If you have any questions or comments that you would like to see as part of this series, please let me know in the comments below, and we will address those as we get them. Thank you very much. Have a great day.